Mass and energy balance for biosystem. Model 4 Foundations of Conservation Principles. Segment 3 System Description and Summary of Use of Accounting and Conservation Equations. Is me, Lily from School of Life Sciences and Technology, Institute Technology, Bandung. In the previous segment, we already discussed about the mathematical framework for accounting equations and also the mathematical framework for conservation equation. And now, in this segment, we will discuss about the system description and summary of use of accounting and conservation equations. A system or process under investigation may be described using terms that characterize a system. Labeling a system accurately will help you identify the correct governing equation, make appropriate assumptions, and incorporate the correct terms of the accounting and conservation equation. When an extensive property across the boundary, it is exchanged between the system and the surrounding, and there are three terms that describe the characteristic of the input and output terms of system. They are open, closed, and isolated. An open system is one that exchanges an extensive property with its surroundings through bulk material transfer, which is the transfer of an extensive property across a system boundary through quantities of mass. The extensive property enters or leaves the system by physically crossing the system boundary. In an open system, either the input or output terms or both are present. It's non-zero. And the movement of mass into or out of an open system can transfer mass, energy, charge, or momentum. A closed system is one that exchanges an extensive property with its surroundings through means other than bulk material transfer. In a closed system, extensive properties do not cross the system boundary through the transfer of mass. By definition, mass and charge cannot be transferred in a closed system. However, both energy and momentum can be exchanged in a closed system through direct contact or non-contact interaction. For the example is a heat. Heat can be transfer of energy through direct contact interaction in a closed system. And also the gravitational force is an example of the transfer of momentum through non-contact interaction in a closed system. An isolated system is one that doesn't exchange any extensive properties by any means with its surroundings. No extensive property enters or leaves the system. In an isolated system, both the input and output terms are zero. And in the engineering convention is to use the term closed, not isolated, to describe system without transfer of mass or charge. The terms open, closed, and isolated are used to describe the accounting of energy and momentum. Describing the generation and consumption terms. Generation and consumption terms describe the creation and destruction of an extensive property within a system. These terms are present in accounting equations describing non-conserved properties. When an extensive property is generated or consumed in a system, the surroundings do not lose or gain. And when a generation or consumption term is present, an accounting equation must be used. There are two main processes constitute generation or consumption of an extensive property. The first one is a chemical reaction, and the second one is an energy interconversion. Regarding to a chemical reaction, A reacting system is one in which at least one biochemical or chemical reaction is taking place. When a system is reacting, accounting equations are required to deal with non-conserved extensive properties. And for non-reacting system, no biochemical, chemical, or other reaction are taking place. The generation and consumption terms in the accounting equation can be set to zero if a system is both non-reacting and without energy interconversion. And the second process constituting the generation or consumption of an extensive property is the interconversion. In a system with energy interconversion, one form of energy is converted to another form, so the first form of energy has depleted in the system and in the universe. When tracking for a specific type of energy, but not total energy, the accounting equation must be used. This table summarizes the types and classification of input-output and generation-consumption terms. Notice that all extensive properties without any generation or consumption terms are conserved properties. For example, the extensive properties of total mass, elemental moles, total energy, net charge, linear momentum, and angular momentum can be neither created nor destroyed in the system and in the universe, and it is appropriate to use the conservation equation for conserved properties, and also using the accounting equation which contains the generation and consumption terms. Describing the accumulation term. The accumulation term describes the net gain or loss of an extensive property contained within a system. When an accumulation term is present, the amount of extensive property in the system has changed during the time period of interest. There are two terms that describe the characteristic of the accumulation term of a system, that is steady state or dynamic. For the steady state is the condition in which the values of all the variables in a system do not change with time, and the system can have input and output terms as well as generation and consumption terms and still operate in a steady state. And in a steady state system, the accumulation term is zero. And for the dynamic state, is a condition in which the values of at least one variable in a system change with time. In a dynamic system, there is a positive accumulation or gain, or a negative accumulation or loss of an extensive property. Changing your assumptions change how a system is described. When analyzing a complex system, it is essential to examine the three categorical distinctions discussed in the previous section. Learning to assess the system, such as open, closed, or isolated, steady state, or dynamic, is crucial to accurate and to find the problem solving. The assumption you make about a system may profoundly affect how the governing accounting and conservation equations are applied and may change the final answer. This table summarizes which equation can be used to count specific extensive properties. Note that the accounting equation is always valid, while the conservation equation is appropriate only for those extensive properties that are conserved. The number of scalar equation is the number of equations that can be written for an extensive property in a system. For example, with elemental mass, One equation can be written for each element n in the system. One scalar conservation equation can be written for net electric charge, and one accounting equation can be written each for positive and negative electric charge. However, only two of these three charge equations are linearly independent, and for the linear and angular momentum are three-dimensional vector quantities. Thus, three scalar, linearly independent equations can be written each for linear momentum and angular momentum. For the next module, we will discuss about the conservation of mass. Until then, I'm Lily from Institute Technology Bandung.